With the right math, you can take the singularity out of the Big Bang. The key, according to mathematicians and personal friends Govert, Kapinski, and Waldron, is to forget about distance and size and instead just think about causality and angles. In probably every description you've ever heard of the Big Bang, as you wind the clock back, matter gets closer and closer together until you arrive at a point where all matter occupied the same place, the singularity. Now, putting aside that we have no idea if that happens at all, thanks quantum mechanics, when we try to study the gravitational behavior of that system, the math throws infinities back at us. After all, you can't divide by zero. But what the authors of this new paper contend is that those issues only arise because we've been caught up worrying about useless things like size. But we don't need to. Instead, they use tools from conformal geometry, the geometry of angles and causal structure, to extract information about the singularity, including things like what kind of matter can exist there. Roughly, they find that 3 different kinds of matter can exist at the Big Bang. The first is perhaps the most expected. Essentially, it behaves like free-floating dust. In relativity parlance, it's a perfect fluid. The next type is pretty strange though. This kind of matter can pass through the Big Bang. Unlike dust, whose density approaches infinity as you approach the singularity, the density of this matter passes through the singularity without changing its density at all. An example of this kind of matter might be gravitational waves. Finally, there's a third type of matter which I don't really have any intuition for. Its density diverges as it approaches the singularity, but less quickly than that of the dust. Unfortunately, I don't have any examples for this matter, nor do the authors. Trust me, I asked. The authors called it Bach matter, and it's basically what causes the curviness in the Big Bang singularity. The actual details of the mathematics is pretty hairy if you haven't seen it before. It uses, I kid you not, machinery called tractor calculus. And if that weren't enough, they're studying the Einstein field equations using tractors. It sounds normal to me, I did my PhD on this stuff, but I can understand how silly it sounds from the outside. And with this machinery, they can go further. They can study a finite energy associated with the Big Bang singularity and a volume too. It's not quite clear mathematically what these mean, but the takeaway from this paper is that the presence of a singularity at the Big Bang shouldn't, and in fact doesn't, stop us from doing physics there.